4 minutes ago, astronomers confirmed something that should not exist. The James Webb Space Telescope had just finished analyzing an explosion so powerful, so long, and so violent that it broke the very model scientists use to explain how stars die. This wasn't a flicker in the dark. This was a blast of energy so extreme it now holds the record for the most powerful cosmic explosion ever, confirmed by human instruments. And the strangest part is, nobody can fully agree on what actually caused it. Stick around, because by the end of this video, you'll understand why some of the world's leading astrophysicists are calling this object one of the most unsettling things Webb has ever seen. Let's start with what a normal gamma-ray burst even looks like, because you need that baseline to understand just how wrong this one went. Gamma-ray bursts are the most violent explosions known in the universe. They happen when a massive star collapses in on itself and forms a black hole, or when two incredibly dense objects like neutron stars slam into each other. When that happens, the universe unleashes a flash of high-energy light so bright it can outshine an entire galaxy for a few brief seconds. Normally, that flash is over fast. Most gamma-ray bursts last somewhere between a few milliseconds and a couple of minutes. Blink, and you might genuinely miss one. That's how these events are supposed to behave. Quick, violent, and gone. On July 2nd of 2025, NASA's Fermi telescope detected a burst that refused to follow that rule. Astronomers gave it the name GRB 2507-ZO2b, and almost immediately, something felt off. Instead of fading within seconds or minutes like every textbook example, this explosion kept firing. It didn't stop after a minute. It didn't stop after an hour. It kept blasting out energy for 7 straight hours, and by some analyses, its activity extended across an entire day. If you're new to this channel, we cover discoveries exactly like this one every week, the moments when space stops making sense, so make sure you're subscribed before we go further into this, because it only gets stranger from here. To put that duration into perspective, imagine watching a lightning strike that normally lasts less than a second, except this one kept striking, over and over for the better part of an entire day. That's roughly the scale of how abnormal this event is compared to every gamma-ray burst ever recorded before it. Ground-based observatories around the world scrambled to get a look, and so did the James Webb Space Telescope. Webb's job was critical. Scientists needed to figure out exactly how far away this explosion was, because distance determines everything. The farther away an explosion is, the more energy it actually had to release to appear as bright as it did from Earth. Using Webb's incredibly sensitive infrared instruments, astronomers located the explosion's host galaxy and measured something called its redshift, which tells scientists how much the light from an object has stretched while traveling across the expanding universe. The results left the research team stunned. This explosion happened roughly 8 billion years ago, and its light only just now reached us. But it wasn't just far away. Once scientists factored distance into the energy calculations, they discovered that GRB 2507-02b was, by a wide margin, the most energetic cosmic explosion ever confirmed. One researcher on the team described it in blunt terms, saying, "This object shows extreme properties that are difficult to explain." That's not a phrase scientists throw around casually. When a postdoctoral astrophysicist working directly with Webb data says something is difficult to explain, it usually means the object is challenging assumptions that have held up for decades. Here's where it gets even stranger. Almost every long gamma-ray burst ever recorded comes paired with a visible supernova, the explosive death of the massive star that triggered the burst in the first place. Scientists expected to find one here too. They searched the region around GRB 2507-02b carefully using Webb's powerful imaging capability. They found nothing. No bright supernova sitting where one should be. That absence opened the door to a genuinely disturbing possibility. If there's no visible supernova, maybe this event wasn't a dying star collapsing at all. Researchers began seriously considering an entirely different explanation, something called a tidal disruption event. That's the scientific term for what happens when a star wanders too close to a black hole and gets ripped apart by its gravity, shredded into a stream of superheated material that spirals inward and radiates enormous amounts of energy as it's consumed. Think about that for a second. Instead of a star simply dying on its own, this could be the record of a black hole actively destroying a star in real time, tearing it apart thread by thread and swallowing the pieces, with Webb capturing the aftermath from 8 billion light-years away. Scientists aren't fully certain which explanation is correct, and that uncertainty is exactly what makes this discovery so unsettling. Follow-up observations using Webb's NER-CAM instrument, its primary infrared camera, gave researchers their clearest view yet of the host galaxy months after the initial explosion. What they found only deepened the mystery. The galaxy itself is massive and extraordinarily dusty, with a thick dust lane running through its structure, making it incredibly difficult to see if anything explosive is still hiding behind that veil of cosmic debris. One of the lead researchers described the situation almost like trying to solve a case with the crime scene deliberately obscured. The galaxy has such a complex structure, she explained, that it's not entirely clear if there's anything left to see of the explosion, and if there is something left, it's so faint it's barely detectable, even with the most powerful space telescope ever built pointed directly at it. This is the part of the story where I want you to pause and really consider what's happening. We're talking about a signal that traveled for 8 billion years across the expanding universe, arriving at Earth in the year 2025, only for scientists to discover that even our most advanced instruments cannot fully classify what produced it. Was it a star collapsing in some entirely new, previously unseen way? Was it a black hole devouring a star alive? Or is it something else entirely, a category of cosmic event we simply don't have a name for yet? Researchers have not ruled any of these possibilities out completely. Some have proposed that the explosion may represent any entirely new class of stellar death, one where a massive star collapses in an unusual and previously undocumented configuration. Others maintain that a tidal disruption event remains the leading explanation, especially given how rarely astronomers have observed events of this type before. As one scientist on the team put it, we've only seen a handful of tidal disruption events like this, so nobody fully understands how they're actually supposed to evolve over time. That's an incredible statement if you sit with it. Even the experts studying this event openly admit that the rulebook simply doesn't exist yet. They are, in a very real sense, writing it in real time, one confusing data point after another. What makes GRB 250702b especially chilling isn't just its power or its unprecedented duration. It's the fact that this event pushed unknown physics right up to its breaking point without fully snapping it. Researchers who modeled the explosion's energy output found that it was enough to strain the standard models used to explain gamma-ray bursts almost to their absolute limit, without definitively breaking them apart. In scientific terms, that's about as close as you can get to physics whispering that something doesn't quite add up, without shouting it outright. If this kind of deep space mystery keeps you hooked the way it kept me hooked researching it, do me a quick favor and smash that like button. It genuinely helps this channel reach more people who love this stuff just as much as you do. There's another layer to this story that deserves attention too. GRB 250702b isn't just interesting because it's powerful. It's interesting because of where it was found. The explosion occurred within an enormous dust-choked galaxy, the kind of environment astronomers don't usually associate with typical gamma-ray bursts. That detail alone has led some researchers to suspect that the environment surrounding the explosion may have played a direct role in creating it, that something about this specific galaxy, its density, its dust, its structure, may have set the stage for an event unlike anything cataloged before. If that theory holds up, it means galaxies like this one, thick with dust and difficult to observe clearly, might be quietly hosting other extreme events that we simply haven't detected yet, hidden behind veils of cosmic material that block our view. Webb was only able to see through that dust because of its extraordinary infrared sensitivity, technology that didn't exist on this scale before this telescope launched, which raises an uncomfortable question. How many other extreme physics-defying events have already happened, completely unnoticed, simply because nothing was watching closely enough to catch them? Scientists are not done with this event. Researchers are now planning long-term monitoring of the afterglow, watching closely for any sign of a hidden supernova finally becoming visible once enough of the surrounding dust settles or clears. They're also building entirely new theoretical models specifically designed to account for events like this one, because the old models, the ones that worked for every previous gamma-ray burst ever observed, simply don't stretch far enough to fully explain what happened on July 2nd of 2025. For now, GRB 250702b sits in an uncomfortable category of its own. Too energetic to be an ordinary gamma-ray burst, too long to fit typical burst behavior, missing the supernova that should have confirmed a dying star, and potentially connected to a black hole quietly destroying a star from the inside out 8 billion years ago in a galaxy, so dusty it's still hiding secrets from the most powerful telescope humanity has ever built. So here's the question worth sitting with. If our best models, our best telescopes, and our brightest researchers still can't fully explain what caused this explosion, what else is out there in the dust and darkness that we simply haven't pointed Webb at yet? Drop your theory in the comments. Tell me whether you think this was a star dying in a way we've never seen, or a black hole caught in the act of destroying something alive. And if you want to be here the moment scientists finally crack this mystery, hit subscribe, because when new data on this event comes in, we'll be covering it before almost anyone else. Let's talk for a second about why Webb was even capable of solving part of this puzzle in the first place, because the telescope itself is a huge part of this story. Before Webb existed, an event like this one would have been almost impossible to fully investigate. Ground-based telescopes struggle to see through thick layers of galactic dust, and older space telescopes simply didn't have the infrared sensitivity needed to peer into environments this obscured. Webb changed that completely. Its mirrors, its instruments, and its position nearly 1 million miles from Earth allow it to detect faint infrared light that has been stretched and dimmed across billions of years of cosmic travel. Without that capability, GRB 25070b might have simply been logged as an unusually long gamma-ray burst and largely forgotten, a strange footnote in an astronomy database. Instead, because Webb could actually resolve the host galaxy in detail, scientists were able to calculate its true distance, its true energy output, and begin building a case that this event belongs in a category almost entirely by itself. It's worth remembering just how young this entire field of study still is. Gamma-ray bursts were only discovered by accident in the late 1960s, when American satellites designed to detect nuclear weapons testing on Earth picked up strange flashes of gamma radiation coming from deep space instead. For years, scientists didn't even know if these bursts were happening inside our own galaxy or billions of light years away. It took decades of observation and increasingly powerful instruments just to build the basic framework researchers use today to classify these events. GRB 250702b is now testing that framework in ways nobody anticipated. There's also a broader pattern here that's worth paying attention to. Webb has repeatedly found objects across the universe that don't fit cleanly into existing categories. Distant galaxies that appear too large and too structured for how young the universe was when their light left them. Strange compact objects called little red dots, first spotted by Webb, that still don't have a fully agreed upon explanation years after their discovery. And now, an explosion so powerful and so prolonged that it stretches the very models built to explain how stars die. Individually, each of these discoveries might look like an isolated curiosity. Together, they start to paint a different picture, one where our understanding of the universe, built up over more than a century of careful observation, is being quietly and repeatedly challenged by a telescope that simply sees further and clearer than anything that came before it. Every time Webb points at something new, there's a real possibility it finds something that doesn't fit, something that forces scientists back to the drawing board. That's exactly the position researchers find themselves in with GRB 250702b right now. They have an explosion with a confirmed distance, a confirmed record-breaking energy output, and a missing supernova that should be there and isn't. They have a host galaxy so thick with dust that it might be hiding the very answer they're searching for. And they have two competing explanations, a bizarre new form of stellar collapse, or a black hole tearing a star apart, neither of which has been confirmed or ruled out. What happens next depends entirely on patience and continued observation. Scientists plan to keep watching this region of space for months, possibly years, waiting to see if a faint supernova eventually emerges from behind the dust, which would support the collapsing star theory, or whether the signal continues behaving in ways more consistent with a tidal disruption event. Every new observation adds another small piece to a puzzle that, right now, still doesn't have a complete picture. 8 billion years ago, something happened in a galaxy wrapped in dust, something violent enough to outshine everything around it for the better part of a day. And only now, after traveling farther than the human mind can truly comprehend, has its light finally reached us, carrying a mystery nobody has fully solved.